Hello, my dear students. Myself Prakash Kumar Das. Once again, welcome you to my channel. That is clear the concept with PK Das. Dear students, it is often seen that many students are facing difficulties when the problems related to parallel or series circuit is coming. But there is no such difficulties if you clearly understand the concept. You see, one of the most often problem that is coming in the CBSE board exam or in the NTSE exam, that is the power dissipated across a resistor. Okay, so the problems related to power dissipation, what knowledge should be there in the minds of the students? That is the most important thing. You see, the question is like this: the power dissipated across a resistor R5 in the network given below is just like this. Here you see a 12 volt potential is connected here, and the series here resistances are there, R1, R2, R3, R4 and R5, pertaining the resistors like 2 ohm, 4 ohm, 6 ohm and 3 ohm and 2 ohm like this. Okay, and the question is asking here, what is the power dissipated in the resistor R5 pertaining a resistance of 3 ohm? Okay, now I will tell you the most simplified method so that any type of problem related to this you can easily solve in a moment. Okay, for this what prerequisite knowledge is required? That is most important. Now you see, for solving this type of problem, a student must have the following knowledges in his or her mind. All of you know that the calculation of equivalent resistance, that is when the resistors are connected in series, that will be the resistances that will be added, that is R1 plus R2 plus R3 like this, and the calculation of equivalent resistance in parallel, that is 1 by R is equal to 1 by R1 plus 1 by R2 ... that will be like this. But I can tell you that for two resistors particularly, it's a better formula you apply, that is R is equal to R1 R2 divided by R1 plus R2. This formula is generally helpful to solve the problem quickly. And the second knowledge you see, that is your Ohm's law. All of you know very well. That is V is equal to IR. And the third one you see, the power, calculation of power in a circuit, that is P is equal to VI. That is the first formula. Then it is I square R, second formula. And then the V square by R is the third formula. So dear students, here in this situation, the dissipation of power can either be calculated with this formula I square R or V square R. Many often it is seen that this formula P is equal to I square R is generally calculated for a series circuit, and this formula P is equal to V square by R, that is generally calculated when the resistances are connected in parallel. Okay. Now, let us go to the problem. How to solve this, or what is the technique behind it? Okay, coming to the next slide, you see, and this is the question. I want to tell you how to solve this problem. Thus the technique is that when you are going to solve the problem, you first calculate the equivalent resistance. Start from the top of the problem. Okay, then as the question is demanded, what is the power dissipated in the resistor R5? You see here, what is the power dissipated in the resistor R5 pertaining 3 ohm? Okay, so here you see, if you look at this diagram, you see, you have to calculate what is the current is flowing across the resistor, or what is the voltage drop across this resistor. If either of the one, that is the current flowing or the voltage drop, you are able to calculate, then the problem will be easily solved. For this, what you have to do, you have to redraw the diagram. Okay, because redrawing the diagram makes a clear vision of solving the problem. So let us discuss the redraw first. You see, this diagram is just given like this. Okay, started with your, this is the first redraw. You see, started with the 12 volt. Okay, here you see, here is a junction. I have made here a junction. Okay, from this junction you see here your R5 resistor, R3 resistor, R2 resistor, and you see the R2 resistor is connected to the end of R4 resistor. So here I have connected this R2 resistor at the end of R4 resistor. Is that clear? Again, after this end, again the R1 resistor is connected and it is finally connected to the battery. So instead of keeping this R1 in the bottom, just for the convenient process, I have kept this R1 here, okay, in the lengthwise you see, and then the line is completed here and connected to your 12 volt battery. Okay, just upon you see, just you concentrate here. The current is flowing in this direction. Is that clear? Now, here it is mentioned that as it is a junction, you see, the current is divided. You know very well. Okay. Why I have written here I by 2? If I current is flowing here, why I have written here I by 2 and also here it written I by 2? This I by 2 current that will be flowing through your R2 resistor, and this I by 2 current it will be flowing throughout this chain, means pertaining your R3, R5 and R4. After that you see this I by 2 current is again coming here another junction, and here the current will again bifurcate. Okay, one part of the current will be flowing here to R3 resistor, another part of the current that will flowing through R5 resistor. So that is important. Let this symbol may be small I. Okay, means what? This I by 2 is bifurcated here. So our aim is to find out what is the current flowing through this. And again you see the 12 volt potential difference is connected across. It is not always true that the same potential that will be created along the circuit. So this R5 resistor will be a different potential, R3 may be a different potential, R4 may be a different potential, R2 may be a different potential. So we have to find out what is the potential difference across R5. So either one, if you are able to get I, it's okay. Or if you are getting able to get a V, then it's also okay. Okay. Now keeping this into target, you see, I am coming to the second redraw now. Second redraw, you see the second redraw. Here it is clearly mentioned that this R5 and R3 resistor, they are connected in parallel. Yes. So by applying parallel connection, just before I am telling you in parallel connection, you just put the formula, that is R1 R2 by R1 plus R2. So here that will be calculated, that what 3 into 6, that is 18 by 9, it will be what? 18 by 9, this will be 2 ohm. So here you see the second redraw, this R5 and R3 parallel, their equivalent resistance is getting here 2 ohm. It's okay. Now these 2 ohm and these 2 ohm, you can see here in the second redraw, this is your 2 ohm, this is your 2 ohm. The bottom 4 ohm is connected here, another this 2 ohm is also connected here. Now after this second redraw, then come to the third redraw. Okay. In third redraw, you see, in third redraw, this is coming as 4 ohm. How 4 ohm? You see, here you can see also this 2 ohm, this 2 ohm and this 2 ohm. Is that clear? This 2 ohm and this 2 ohm, they are connected in series. Okay. So 2 ohm plus 2 ohm is a series, the resistor will be added. Accordingly 2 ohm plus 2 ohm 4 ohm, and here is also 4 ohm. So it is the third redraw, that is 4 ohm, 4 ohm, another is remaining 2 ohm. Now in the fourth redraw you see these 4 ohm resistors are connected in parallel. Therefore I have calculated in parallel again the same fundamental, that is R1 R2 divided by R1 plus R2. R1 R2 is 4 into 4, that is 16. 4 plus 4 is 8. So 16 by 8 is equal to 2 ohm. Okay. Now in the fourth redraw, this you see this one is the 2 ohm and this one 2 ohm, and they are in the series. So finally the equivalent resistance is coming as 2 ohm plus 2 ohm, that is 4 ohm. Is that clear? Now in the fifth redraw you see the equivalent resistance is 4 ohm and the potential you are getting 12 volts. So applying Ohm's law here, we calculated as V by R, then your I is coming as 12 by 4, that is 3 ampere. Is that clear? So here you are finding out the equivalent resistance in the circuit breakdown, or that is called as redraw of the circuit. Now started from this redraw of the circuit, you have to go from the back to the top. What is the potential difference created across the R5 resistor? Okay, do you get me? So let us move from the back to the top now. Okay, now it's time now. We have to calculate the current flowing across R5 resistor or the potential difference created across your R5 resistor. So before going to this, I can again concentrate here. Dear student, you see, I have written here, when the current I is flowing here at the first junction, here the current is becoming I by 2, and here is the current is also I by 2. That means half of the current is flowing through R2 resistor and half of the current is flowing through R3 resistor, or this R3 or R5 or this R4, this chain of your circuit. And why it happens? Always you see, always this current will be divided equally. That is not the point. It may be different. But here in this situation, why current I is becoming I by 2 and I by 2, you can easily understand if you go from the back. Now, all of you concentrate here. Now, we have drawn all these 5 redraws. This is the first redraw, second redraw, and your third redraw, fourth redraw, and fifth redraw. Now you see, here the R equivalent, the equivalent resistance is coming 4 ohm, and here is the potential difference, that is 12 volt. So we can calculate by applying Ohm's law, that is V is equal to IR, or I is equal to V by R, that is 12 by 4 is equal to 3 ampere. So current flowing here 3 ampere. Is that clear? When the current is flowing 3 ampere here, you see this 3 ampere is current to this 4 ohm resistance. Again, come back to the fourth redraw. You see, here is also 3 ampere current is flowing. Is that clear? Now, this 3 ampere current, here it will also flow 3 ampere, and here it will also flow 3 ampere. Why? Because we know that in a series connection, I is becoming constant. Now, this 2 ohm resistance and this 2 ohm resistance are in series. So, this 3 ampere current will flow here as well as flow here. Now, if a student will be able to calculate what is the voltage drop across this and across this, it will be definitely 6 volt. Why? By applying your V is equal to IR. So I is equal to 3 ampere and R is equal to 2 ohm. So V is equal to IR, 3 into 2, 6 volt, and here is also V is equal to IR, 3 into 2, 6 volt. So here it will also 6 volt. Now you see 6 volt plus 6 volt, finally it will be again 12 volt. Now again coming to this point, now jump over to the third redraw. This 6 volt potential is created across the 2 ohm. Now this, how this 2 ohm is obtained? If you coming to this third redraw, you see this 2 ohm is obtained by what? By your parallel combination of these 2 4 ohm resistor. Is that clear? So when the parallel resistance of 2 4 ohm resistor is coming here, so this one is also get 6 volt and this one also it will get 6 volt. Okay. Now here you see in a parallel condition, you combination, you see these two at the same potential, maintaining the same potential, and here is also 3 ampere current is flowing. But if you calculate back, you see you will get the I here. What will be the I here? The current flowing through these two resistors, that will be I by 2. And I was telling you previously why it will be I by 2. Now you see, as both of the resistances are same, so equal amount of current will be flown, or the current will be here I by 2. But if they will be two different resistors, then it will be not happen. Here is also what? Here is also flowing I by 2. I by 2 you calculate here, that will be I by 2 definitely, or you can reverse calculate it, that is I is equal to V by R. So I is equal to V by R, that is 6 by 4 is nothing but 3 by 2 ampere. So here it is getting 3 by 2 ampere, and here is also you will get what? 3 by 2 ampere. Now you see 3 by 2 ampere, how this again come to the second redraw? Do you get my point? Second redraw, this 3 by 2 ampere, this 4 ohm resistor is made with series connection of 2 ohm resistor. This 2 ohm resistor, this 2 ohm resistor, they are 4 ohm resistor. Are you getting my point? So if here is current flowing 3 by 2 ampere, so this will be also here 3 by 2 ampere, as well as here is also 3 by 2 ampere. Is that clear? Now when here the current is 3 by 2 ampere, is that clear? Now let us jump over to the first redraw. You see in the first redraw, this 2 ohm resistor is made up of by the parallel combination of R5 and R3, that is 3 ohm or 2 ohm. Is that clear? Now let us calculate what is the voltage drop here. You see voltage drop will be here, V is equal to IR, that is 2 into 3 by 2, that will be your what? 3 volt. So across the 2 ohm resistor, the voltage drop is here 3 volt. So here how this 2 ohm resistor, this equivalent resistor is made? This 3 ohm resistor, this 2 ohm resistor is made by equivalenting what? These two parallel resistor, that is your 3 ohm and 6 ohm. So here voltage drop will be also 3 volt, and here the voltage drop will be also 3 volt. Do you get my point? Okay, so we are getting that R5, the voltage drop we are getting in the R5, that is 3 volt. Okay, now what will be the power dissipation? We can calculate. Power is dissipation here. If you calculate V square by R, you see that is 3 square by 3. Okay, this is 9 by 3 is equal to 3 watt. Okay, so power dissipation across your R5 resistor, okay, that will be coming 3 watt. Suppose a student wants to calculate the current flowing here, I. Okay, no problem. If you want to calculate the current flowing here, also you see across R5, what is the current? Across R5, you see, we know again across R5, the current I is equal to again V by R. This is equal to 3 volt by 3 ohm is equal to 1 ampere. Okay, if you also put the formula P is equal to I square R, then also this is 1 square into 3 ohm. This is again 3 watt. So finally we are getting that the power dissipated across your R5 resistor is coming to be 3 watt. So dear students, you have seen that how easy it is. If you start calculating from the what bottom. Once again I am telling you, repeating the concept. You see here is the equivalent resistance 4 ohm Potential difference 12 ohm. So net current flowing in the resistor, that is 12 by 4 is equal to 3 ampere. Okay, now this 3 ampere, here you see, now come to this fourth redraw. This 3 ampere current will pass through this 2 ohm resistance connected in series. As in the series, your current is I is constant, so 3 ampere current will flow through it, and 3 ampere current will also flow through it. So potential difference across this resistor will be V is equal to IR 3 into 2 6 volt. Here is also 3 into 2 6 volt. Now how this 2 ohm resistor is made? This 2 ohm resistor is made by the parallel combination of 4 ohm and 4 ohm. Okay, so this 4 ohm resistor will have the potential difference of potential drop 6 volt, and this is also having 6 volt. Now if here we calculate the current as this 4 ohm resistor are two equal resistance containing equal resistance, so current 3 ampere flowing through this, it will be I by 2, 3 by 2, automatically 3 by 2. If you want also reverse calculation, here you see voltage is V, 6 volt and resistance is 4, so 6 by 4 is nothing but 3 by 2. So here in this case, here your current will be flowing, what? 3 by 2 ampere. Is that clear? Now this 4 ohm resistor, how this 4 ohm resistor is again made? You see, this 4 ohm resistor is made with two series circuit of 2 ohm resistance. Then you see this 3 by 2 ampere current will flows through it. This 3 by 2 ampere current will also flows through it. Now what is the potential drop across this? V is equal to IR. So 3 by 2 into 2 is 2 cancel, you see that is 3 volt. So the potential drop across this 2 ohm resistor is 3 volt. But this 2 ohm resistor is the equivalent resistance of these two. Is that clear? Coming to the fast reader. So R5 will be also a potential drop of 3 volt, and your R3 will also a potential drop of 3 volt. Now you see across R5 potential difference is 3 volt and your resistance is 3 ohm. So applying your power dissipation across R5 is equal to V square by R5, that is 3 square by 9 by 3 is equal to 3 watt. And here also, if you want to calculate the current, the same thing here, what current will flow through I5, that is your V by R, I is equal to V by R, so 3 by 3, here I is equal to 1 ampere. Okay, so where I is equal to 1 ampere, so I can put, if I want to put P is equal to I square R, this is I 1 ampere, 1 square into 3 ohm, is that clear? Nothing but your 3 watt. Yes. So dear students, this type of problem is generally calculated in this way. I expect that you are understanding the concept properly. Whatever the diagram may be, first you calculate the equivalent resistance. After getting the equivalent resistance, from the bottom you go to the top to calculate the individual current flowing through a particular resistance or individual potential drop for a particular resistance. Then and then you can calculate the power dissipated. Now if any students want to calculate what will be the power dissipation across R4 or what is the power dissipation across R1, accordingly you can calculate it. Okay, then if you are liking the video, please like, subscribe, share and comment to my channel, that is Clear the Concept with PK Das. For more videos you subscribe it. Till then, thank you.